Hello everyone. From now on, we'll do hands-on projects starting with Tinkercad. Tinkercad is an online simulation tool using which we can do 3D designs, circuits, and code blocks. For IoT course in IIIP, we use circuits alone. In Tinkercad, we have many resources to use like potentiometer, DC motor, servo motor, ping sensor, etc. Let us do a simulation in Tinkercad now. Feel free to pause the video whenever required. Open www.tinkercad.com and click on the Join Now present on the top right corner. You can click on Create a personal account. You can sign in via Google, Apple, Facebook, or Microsoft accounts. I already have an account and I am logging in with it. After you log in, you will be redirected to Dashboard. On the left side, you can see Circuits. Click on Circuits and click on Create a new circuit. Let us explore the project. Coming from top left, whenever you create a project, it will assign a random name to it. You can change it by tapping on it. I'll change it to Blink LED and press enter. Below icons are having some functionalities which you'll understand when you add a circuit. On the right hand side, you can see something called as all changes saved, which shows the status of current project. You have two icons beside it. One is circuit view, where we can build the whole circuit, and other is components list, which lists out all the components we have used in the circuit view. Below that, you have code, where you can code, start simulation, where you can start simulation once we complete a circuit, export to export a project, and share to share a project. We can revisit these once we build a circuit. Below those, you can see components that are by default selected as basic. I suggest you to select this to all. But before this, I suggest you to select starters all, where you can click on the blink and examine the circuit. This icon will show the list view, and if we click it again, it will show the grid view. You can see that the Arduino is not connected to power as we did not click start simulation. One terminal of LED is attached with a resistor to the 13th pin, and the other terminal is grounded. When we click on resistor, we can look at the resistance value which comes on the top right corner. Here, resistor's value is 220 ohm. Now, let's explore the functionalities which we skipped before. Click on the resistor and click on the rotate symbol. The resistor gets rotated. We can even click R to rotate the resistor by 30 degrees and Shift plus R to rotate the resistor by 30 degrees anti-clockwise. The resistor will be deleted if we click on the delete icon or the delete key. Don't worry, if we click Ctrl plus Z, we can undo it and the resistor comes back. there is something called as annotation and view or hide. The annotation is hidden and shown whenever we click on view or hide. Beside those, you can see wire colors and wire types which we can assign according to the convenience and requirement. Please remember one thing. Always give the wire color as black whenever we need to ground and red whenever we connect it to high or VCC. VCC means voltage common collector, which has higher voltage when compared to the ground. Now click on the code. It is selected as blocks. Let us see what is written here. The first one is a notation which says that this program builds the pin 13 of the Arduino, that is the built-in LED. Below that is the code to turn the LED on and wait for 1 second, and below that there is the code to turn the LED low for 1 second. When we click on export, we will be getting a pop-up which suggests us to download a .brd file. BRD full form is business requirement document and we will use to import a project. When we click on share, we can save a snapshot of the circuit, or we can even share the link of the project. Now let us experiment with the circuit. Let us remove the resistor and directly connect the terminal to the 13th pin. Click on the start simulation and you will see an exclamation mark. Let us change the code, that is the turn on time, from 1 second to 10 seconds. Now let us click on the start simulation again. If we see, it says that current through the LED is 52.3 milliamperes, while recommended maximum is 20 milliamps. So we are giving more current which LED can't resist for. And hence we are adding a resistor to decrease the current flown into LED. And hence initially 220 ohm resistor is added. Calculating maximum resistance is beyond the scope of this course. However, after experimenting, I found out that 88 ohm is termed as the minimum resistance, below which if we add, LED might get damaged. A quick question to you all. What will happen if we remove the black wire and click on the start simulation? Think yourself, and the comment box is all yours. The best explanation is pinned and appreciated. This is the end of the video. I'll give the answer in my next video. Thank you.